My name is Jason Park. I am the current research head in Riiid. So before we get started, I do want to ask all of you who have been studying data science to a certain degree, what type of questions should an AI tutoring system recommend to the student to maximize projected grades? If you could just go ahead and type in any type of answers that you have, and I'll just give you a couple of minutes and see what you guys think about this. Okay, so there are a lot of interesting answers. So there are really two perspectives to answer this question. There's a learning science part and the AI part. Learning science part is more similar to most of the answers that were given, like questions the student had performed poorly in the past, on the things that they don't know, the most difficult. However, if you think about this carefully in an AI perspective, the answer is actually an easy question that the learners likely get correct. The reason why is because a score prediction model will utilize the interaction data in order to project it into a grade. But that's not necessarily the best thing for the student. That's not necessarily the most educative and that provides most value to the student, because the student is not trying to get a high projected grade, but they're trying to get knowledge. They're trying to learn more things from using the AI. So you have to really think about this in a very, very coarse way. You have to think about what it means to the user and what AI can provide. So at Riiid, we have three core technologies that we're trying to optimize in order to benefit and value each students. The first is called knowledge tracing. The general concept of knowledge tracing is being able to assess the student's ability, the knowledge state the person has at a certain point. And using that, we could do different interesting things like correctness prediction, whether a student would get a new questions correct or incorrect. Score predictions, such as estimating your SAT scores, your GPA, and different things like that. Where all of these mash together and provide the ultimate goal is through a recommender system, a recommended content curation where each student is provided with the most appropriate and the most effective content material that will maximize their scores. So, knowledge tracing. Before I do go into this, I do want to state out that I don't want to discuss the specific models that we have in too much detail. Like, I want to provide you with an insight of how research is being done at Riiid and how the methodology is being developed in order to provide the most benefit for the users. So I'm going to be skipping through a lot of the details, but nevertheless, feel free to ask at the Q&A. So at knowledge tracing, we have a very specific type of data, user interaction data from utilizing our app Sanatoic. What happens is that users get a sequence of answers, correct or incorrect, and we utilize that in order to assess the student's ability. What's really interesting is that this is not necessarily the way that it was being done at the educational technology industry. What usually happened was we provide a specific feature and we analyze it in order to provide a level of knowledge state in a different knowledge component or different types of material, contents. But we wanted to go deeper, and we thought about this, and when we decided to move into utilizing the actual interaction question sets, what happened, what interesting was that it resembled a lot of what happens in natural language processing. The time series function of interaction data was very, very similar to what happens in natural language processing. And we wanted to use the best models available in order to do that. And that's one of the reasons why we utilize a lot of NLP techniques. We started with our recurrent neural networks, LSTM, GRU, and different time sequence models that are appropriate for natural language processing was very, very effective when being used on interaction data. And then, as you all know, the transformer network came to life. Attention is all you need paper is a phenomenal paper that propelled our AI models into the next generation. So we utilize a transformer network and utilize each interaction sequence in order to predict what happens in natural language processing is something like classification of sentiments, emotion, different categories. Similarly, we do that with questions, whether the next question will get correct or incorrect, depending on the student's past behavior. Then we move on to score prediction. So ultimately, just being able to know the latent space and the knowledge state of the user is not sufficient because it's not very interpretable for students. We wanted to translate that into a very concrete and raw number. And that was what we've done in score prediction. And as some of you will probably have guessed, but since we started using transformer networks, we've thought about this paradigm a little bit more. And BERT came. BERT is a natural language processing methodology that almost changed the industry in a way because it provides a language model, which is very, very, very effective in multiple different category tasks without having to train it end to end every single time it's being done. The pre-train and fine-tune methodology. At Riiid, we were thinking about this. Can we use this in a similar setting such as ours? And the answer, as our paper on assessment modeling shows, that we can. Although the language model, the specifics of the language model, the semantic relationship between each tokens are not necessarily replicated here because that's not the type of test that we are trying to do. However, we did want the knowledge state to be some sort of conjecture of all the questions. And we wanted to really understand the relationship between the questions. And the pre-training methodology has proven its effectiveness at score prediction. And we've diversified the tasks of fine-tuning into different areas such as dropout prediction and on-time management, different fine-tuning tasks. And we found this very, very effective and very, very exciting. And where all of these come together, as I've told you before, is recommended systems. Educational material is slightly different from what happens at Netflix or Amazon. Because what happens in Netflix and Amazon is the materials are predicted and recommended based on their preference level. So whether a student would like this or not, or whether a user would like this or not, is quite irrelevant in education in a way that it doesn't necessarily match the level of learning gains that happens. So we took a different approach and we've managed to narrow down the problem space into something that is very similar to reinforcement learning. In order to do reinforcement learning, we need an environment, and that environment is built on knowledge tracing and score prediction. It's a simulator of a student's ability and what the projected new grades will be. So when a user comes in, we assess their user's knowledge state, and then we provide questions based on their difficulty and whether the student will get it right or wrong, and also the amount of score that it will increase. Hundreds of steps later, we train a very, very effective personalized learning and maximized recommendation system that ultimately just aims to increase the user's score. There's a lot of caveat to this. There's a lot of different mathematical problems that are associated with it, but that's just part of what Riiid research is always focused on. And we're trying to solve this in order to not only maximize the outcome, but really, really translate it to a benefit. So recommended systems, like the caveats that I've just explained, there are a lot of different things in a recommended system that needs to be improved and can be diversified too. For example, diagnostic question is a type of a cold start problem, because when a new user comes in to utilize a system, there's no data on the person. But in order to maximize the ability of our knowledge tracing, we need to figure out the right questions to ask. Asking the right questions would maximize the accuracy of score prediction and therefore maximize the performance of recommender systems and provide the most value to the user. And there are a lot of different things that we could do to improve our recommender systems. Right now, our main recommender model only focuses on providing specific questions and analyze what type of score gain that could provide. However, we could move further than that and provide different learning content such as lectures, vocabularies, videos even, and different types of content that provide a meaningful relationship for your actual learning gain. And simply improving the simulator that we have of knowledge tracing and score prediction by using different complex user states would also be very, very beneficial. And if those who are familiar with reinforcement learning would probably understand the concept of rewards. The simple reward of estimated score change might not be enough. We might want to dig deeper and provide a more sophisticated reward that can cover different areas such as personal interest, retention, and even specific knowledge components. So if we do that, we could probably target the weakest areas of the learners instead of just focusing on actually increasing the score, which is very often very, very similar. In order to do all of this, what we need is data. What we need is quality data that is very well labeled in order for scientists to dig deep and provide understandings and analysis of how the relationship between questions, learning contents, and the actual scores are. We already have the largest data sets in known and publicly open educational settings, more than 300 million interaction data from around 700,000 students. If we have more data, the quality of the model will increase. That's pretty self-explanatory to all of you because you've been studying data science. But what's important is that, can we really specify what the right data needs to be? What features are more required for the models to be more sophisticated, more diversified, and can provide more understanding to us? When we do this, there's an interesting cycle that happens. When we're building a model, we identify the weaknesses and we can find out what data we are needing. And when we have that data, we can provide a better algorithm, better models in order to provide more value. And then the cycle continues. More data, more features, more models, and then require more data. But we're not necessarily trying to just do this on our own. We've had a lot of different discussions about whether or not to publicly open our data sets. And our decision was that we want more people in the educational technology space and artificial intelligence space to join us in terms of finding a better solution. Like ImageNet and a lot of different NLP benchmark test sets, we've publicly opened EdNet, which is the largest public AI education data set with more than 1 million students and 150 million learning interactions. And we wanted to go further, and we really wanted to propel this innovation and initiative by starting a Kaggle challenge for Riiid's knowledge tracing task. So I'm aware that a lot of you have already tried and competed within this competition, but it was a phenomenal success. More than 3,000 teams, more than 60,000 models from 100 different countries. And at Riiid Research, we are very, very, very interested in all the details, all the features, all the modeling techniques that have been employed in Kaggle. And we want to continue on with this direction, this momentum, so that not only people who are interested in education, but people who are interested in AI would join us in the step forward into the future in providing the most beneficial educational product utilizing AI in the future.